What's going on, everybody? How's everyone doing tonight? We'll be streaming Advent of Code Day 9, I think is what's coming out. So yeah, we'll be doing Day 9. We will be racing the world-famous Bad Cop. So she'll be joining us in the next 15 minutes, and the puzzle drops in the next 15 minutes. As you can see, I got a new patch set up on my piano. It's got a nice little reverb, so very aesthetic tonight. How did your day 8 go? Which one was day? Was that just yesterday? I got bodied by part 1. It was the 3D space one, right? I got bodied by part 1. It was really, really dumb. I got just hung up on the basic algorithm. But once I got part 1, I think part 2 took 2 minutes. Like once because I did part 1 the hard way, basically. And once I got it, I was like, oh, wait. I also kind of misunderstood some of the initial instructions. If I had like understood them better, it was like, you know, skip over this action. I didn't realize skipping over it counted towards one of the things. If I had gotten that first, it would have been good. But yeah. You did the same misinterpretation. That does make me feel better. Yeah, I feel better about that. I realize... No. I don't know what I realized. That was... I don't know where I was going with that thought. No, yeah, I made the same misinterpretation. I was like, I read it. I was like, oh, so we skip over it. But if you read the instructions, it's like, okay, that's one of the things that had to be done. So that it makes sense. But yeah, I wish I hadn't made that mistake. Yo, thank you for the luck in the YouTube chat. Appreciate it. Let's see. I got Lost the Sauce golfing with Hannah in Bad Cops chat while she did the visualization. Ha! That's funny. And then, what do we have here? It was slow for me, even in C#. Took like 40 minutes for part 1. Yeah. Also, the 1,000 smallest distance, not 1,000 pairs. Yeah, dude. Yeah, that crushed me. I didn't like that it was 1,000 and 1,000. I've learned when I get stuck, reread the instructions very carefully. That's pretty much what ended up happening there. Like, I absolutely ended up doing that again. I just tried to load that Reddit link twice and got an internal server error. Both times gave me a 500. That was interesting. Oh, you got the golf solution up here? Oh, God, look at this bad boy. I'll put it on chat for people, or put it on screen for people curious. Yeah. Wild. Wild. I love the deprecated math syntax. That's just clever. You complained to Eric about it? Interesting, yeah. I know Eric is very careful to word things the way he does. So, like, I'm sure there's a very good reason. But, yeah, I'm sure he probably appreciates the feedback. Let's see. I just looked at my time. Part 1 took 46 minutes. And part 2, 3 minutes. Yeah, dude. I feel that, man. Here we go. Let me go back to the big camera. We're not quite ready to get started yet. Super Hate Me World. Yo, love your song Safe House. Yo, appreciate it. What a nice comment. The fact that anyone goes to like Spotify or my YouTube and listens to the music I actually write is awesome. I just don't expect people to. I haven't played Safe House in a while. Something like that, right? I'd have to relearn. I have to relearn my own songs. I have too many. Wait, hold on. That's Echoes of Solace, yeah. That's Undercurrents. If you guys can't tell, if you're new to the stream, don't worry, let me just pan the camera down real quick. Yeah, I got this going on, so. Yeah, those are songs off my album Nightfall, which you can find on Spotify or whatever you guys like to stream. The artist name is just my first and last name, Dave Eddy, D-A-V-E-E-D-D-Y. Go there and you will find my music that I write, so go check out those albums. There's a bunch of weird electronic stuff under there too. I didn't bother splitting into a separate artist, so I mean, a lot of those songs, like, they're not that great. I don't say that in like a deprecating way. I just like my instrumentals better. Thank you, Dark Space. What a nice compliment. Don't forget, you can also listen to my album in your terminal. I probably showed this off before. Let me see if I can share this. I have to make the terminal the right size. I know you can't see what I'm doing, don't worry. So here, I'll show you. Yeah, so if you have a terminal at home, you can run curl nightfall.ysap.sh, and that is my album. Now, the thing is, it gives you a bash script. You can go there in your browser, too. It gives you a really nice website. But it gives you a bash script. So then you pipe it to bash, and it will run. Now, as you can see, my terminal's too small. So let me pan over to a different terminal that's way smaller. You can't see it, but I'm going to curl nightfall.ysap.sh and pipe it to bash. And you get this. So you can play my actual album. And when I say play, I mean it will stream from my server. So let me pick a song like Echoes of Solace and hit enter. And it's playing. I know you guys can hear my desktop audio. It's pure bash. I think it forks out to like one command, STTY. It might, oh, does it make a FIFO? It might fork out to make FIFO. Might fork out to sleep. I don't know, whatever. It's mostly bash. I have a video on my channel where I talk about it, but it uses FFmpeg to play the music, so FF play technically. So you can scroll up and you can pick a different song, and it will just cancel that current song. When the song finishes, it'll automatically go into the next one, so I react to events from FF play and from the keyboard event, so that means I have to have two separate threads running that communicate to the main thread, so that's why pipe is being used there. So, yeah, pretty cool. Pretty neat stuff over here. Used to do mixing for live shows. Dude, that's pretty cool, man. Stream from your server, BRB, you're gonna spin up a few lambdas. Yeah. Nice try. If you do that, it'll probably work. Don't do that, please. Let's see, we got 7 minutes. I'm sure we'll hear from Bad Cop soon. And, unless she's already creeping my stream. Oh, man. All right, I'm ready to fire it in there on this problem. I'm very excited. I love Adventico, dude. It's so much fun. Yo, yo, what up, G-Baby Sleaze? How you doing? Welcome, welcome. Let me fire open the browser over here. Huh. I don't want to spam Eric's server here, but look at this ASCII animation or picture. See the top where like there's little dots for snowfall? I'm gonna refresh the page. Watch the snow. The snow is RNG. How funny is that? And it doesn't line up with what the 2025 is, it looks like. The snow is RNG. How cute. So, if Eric decides to grace us with his presence tonight, I will ask about that, or at least point it out and be like, hey, I noticed something fun about this. I'm curious what this animation is, because obviously, like, this is like the ground, right? Like, here's a snowman, here's like a lamppost, and here's like this, and there's like a whole underground like bunker thing. So like, I'm curious what this whole thing will look like when it's decorated. It'll be really cool. And honestly, one of my favorite things about the animations that like, or the animations, the images that Eric has for these is like, there is this version, the grayed out version, which is you haven't solved anything, and then there's like a version where you've solved like 1 star out of 2. So like you can paint like your own picture by solving different puzzles. Like, it's really cool. Spam the server is probably getting less load now than ever. You know what? He's probably oh man, Eric, post the load graphs. Graph it out. I want to see the fluctuations. I want to see how crazy it gets when midnight arrives. When the clock strikes 12. That's what I want to see. 2019 is really cool. Oh, good. I just got a bitrate warning on both YouTube and Twitch. So hopefully my internet doesn't cut out, because, dude, that was garbage, man. Hopefully it doesn't happen like last night. 2019. Ooh, that'll be fun. Best puzzle and best art award for me. Oh, man. Okay. Yeah, I know. 2019 is it's a special one. It's I believe you make something, from what I've heard, you know, it's the encode one, but you carry through the puzzle. Like, you kind of almost have to do it sequentially, which I'm up for. Like, I'm excited for it. I love that. The oh hell no moment. I can respect that. I might get a persistent ping going to an external source. Okay. The internet's working. Okay. Just wanted to make sure. Sometimes my bitrate drops a little bit. Like I said, I locally record all this, so it's not the end of the world. And if you want the higher quality VOD, obviously go to YouTube. It's all there. I will go through and edit up these VODs and cut out a lot of the yapping and stuff and just put like the puzzle part of the challenge on my channel. I don't know how well those videos even do, or if they even hurt me in the algorithm. I have no idea, but I like to do it. I think they're fun. And it's a cool way for people to discover my content. I'll be back around sometime after Solve It. Maybe see you soon. Good luck. Hey, good luck. Yeah, I hope sooner rather than later for both of us. I'm going to hit Bad Cop up with a warning. A 3-minute warning. Just to let her know. More videos, more better. Dude, I agree. I think that's fine, because the YouTube algorithm's pretty good. Like, if your audience doesn't like a video, it doesn't hurt your channel. It just, like, that video just doesn't perform well. Like, I respect that. I think that's kind of like a baller move, so, yeah. And I don't have many videos in the work currently. Normally I have like 1 or 2 videos banked up. I don't have any because I've been focusing on this stupid bash course. So I won't have anything like super interesting to upload to YouTube until I get this bash course out, which will be in the next week or 2. I also don't even have any shorts going up. I'm just kind of slacking. But, you know, this isn't my full-time job, so I'm not worried about it. Oh, we're getting a call. Let me take this call. Yo, what up, gamer? Oh, did I just do a video call with you? I'm stupid. No, I did a video call on Discord. I just clicked the video button. I unclicked it. We're good. We're good. Wait, are you streaming? Are you streaming right now? I don't even see you streaming. Oh, okay. Never mind. I see it. Yep. Oh my god. All right, well, we don't have much time. Well, we do. We have 1 minute and 11 seconds. That's what I'm saying, actually. Oh, I'm not even... They can't hear you. There we go. Now your audio's on. Now they can hear you.
Nice.
Nice, nice. We got Bad Cop on the call.
I know how to do this.
Yep.
Did it work on this thingy?
I didn't see anything pop up on Twitch.
Let me click the knock button.
First time catching you live? Yo, what up, what up? Welcome, welcome. I'd read your whole message, but I'm about to get into a race in less than 1 minute, so I don't have time. Sorry. Except, I got the stream together.
There's no time.
There's no time for this.
Like
okay.
present.
Wait, why do I hear you coming out of the Twitch thing? Oh god, ew.
Oh, I can fix that.
Okay, thank you.
You gotta click your camera on.
I am. Doing it.
Oh,
there we go.
Okay.
Now we got you up there.
We did it in time, easy.
We did it. Oh my god.
Want to talk about? All right, let's start.
We have 10 minutes. Or 10. No, 7 seconds.
10 seconds.
Woo, woo.
My terminal.
I know I'm not in the right directory. All right, jumping in. Good luck.
See ya.
Okay, she's muted. We're gonna speed through this. We're doing Advent of Code and we're racing. If you're sending me lovely messages, I appreciate that, but we have to go fast here. Okay. Day 9, movie theater. You slide down from the fire pole in the corner of the playground and land in the North Pole base movie theater. The movie theater has a big tile floor with an interesting pattern. Elves here are redecorating the theater by switching out some of the square tiles and the big grid they form. Some of the tiles are red. The elves would like to find the largest rectangle that uses red tiles for 2 of its opposite corners. What? They even have a list where the red tiles are located in the grid. Your puzzle input. For example, also you can triple click it to select the whole thing. I read that in the FAQ. So... hello, there is a lovely message. Thank you, Eric. Oh, wait, no, I'm not supposed to read that. Eric, I read the FAQ today. Like I've read it a bunch of times, but triple click. Thank you. That's beautiful. Oh my God, I'm so fast now. I'm going to stop getting distracted. Showing the red tiles as a hash mark and the other tiles as dot, the above arrangement of red tiles would look like this. Okay, cool. You can choose any 2 red tiles as the is there like a width and a height? We'll figure that out later. You can choose any 2 red tiles as the opposite corners of your rectangle. Your goal is to find the largest rectangle possible. For example, you can make a rectangle shown as O with an area of 24 between these 2 things. Okay, cool. Or you could make a rectangle with area 35 between 7,1 and 11,7. Okay. You could even make a thin rectangle. Okay, ultimately the large rectangle you can make in this example has an area of this. Okay. Using the 2 red tiles as the opposite corners, which one is the largest area? Okay, cool. Awesome, awesome. So we're going to go ahead and we're going to start copying some stuff over to the terminal. So we have this make dir day09, cd into that, vim example input.text, paste that in there. Nice. Vim real input.text. I'm not going to show this part to you. This is a secret. The contents of this box are a secret. All right, cool. So we paste that in. So now if we pull up the terminal, look at this, do a nice little word count -L on these, and here is what we have. Awesome. So was there something that said what the main size of the thing is? Which I guess doesn't matter. If we're using them as corners, we can't actually go past the corners of the grid. So we just need to have enough room for the biggest that we see in both directions, unless it's somewhere in the instructions. Showing the red tiles as the pound sign here, the above arrangement of red tiles like this. Yeah, so I don't actually think it matters the size of it, because we just need to be able to house all the red tiles and we can use them as corners. So it's not really a big deal. So we just need to find the largest X and the largest Y and make it of size that -1, +1. I don't know, whatever. We'll figure it out. We're smart. I wish more people would read the FAQ. Eric, I have some ideas about getting people to do things that you want, because I've learned as a content creator how to get people to do the things that I want, because I crave their validation, and I've learned how to get it by being not slightly manipulative, but I know how to talk in a way to get people to listen and pay attention to the stuff that's important. We can talk after this. Make a part 1, user bin env bash chmod, that's not right, +x part 1. There we go. Now we will go ahead and we will read the entire thing. And what is the format of it? It's x comma y. So we will do a while ifs equals comma read -r xy do done, and then we can say key equals, look at this, we break it apart just to put it back together, x comma y, and then we do map key equals the pound sign. There we go. Declare -cap a map. Okay. There we go. So now we have a nice little map here, and we put the pound signs in it, so now we know where they are. So now we need to go through and we need to keep track of the width and the height. We will initialize those to 0. And then we will say this: if x is greater than width, then width equals $x, and then we'll do the same for y and height. And then down here, we will do width plus plus and height plus plus because, you know, the width is going to be 1 above where it is. So here we go. I need a Santa hat, dude. You're absolutely right. I don't think I have one. Like, that's no excuse. I should just go pick one up. I'll do it tomorrow. Part 1, cat example, pipe into part 1. Okay, we have a width of 12 and a height of 8. That means the highest number in the x is 11 and the highest number in the y is 7. If we look at the example input, that seems to make sense. Nice, nice, nice. So now, to find the biggest area, I mean, we just calculate them all. Like, I mean, we just calculate them all and find the biggest one, right? Like, yeah. For I equals 0, I less than the length of map. Let me think about how I want to do this. Okay, we got it. The length of map I plus plus do for j equals I plus 1, j less than the length of map j plus plus do. This should be -1. We don't want to check the last one. Done, done. So we have read dash r x and y. So we're going to pull these two things out of the map. So we have the map at I. We need to loop over the keys. We're treating it like an indexed array.
Easy.
We're treating it like an indexed array. That's our problem. You already got it done? Oh my god. That's incredible. You're just faster than I am. That's as simple as that. I know what to do. I just haven't coded it yet.
I just wanted to type really fast to, you know.
Well, you do type faster than me. I think your words per minute were like 120, 130. I think mine was like 90. So you got me there. Well, nice job. I'm going to continue on with what I have because I think, I pretty much think I have the algorithm down. So we'll see if I can get it to work.
All right.
All right. Good luck. Yeah, go for it. Go. We don't even need to ask. Go start day 2. You got this. All right, chat. We're back. We're gonna do this. We don't even need to store it in an associative array. We're just going to store it in a regular index, and we'll just call it points indexed array. So we'll just say points plus equal the key. There we go. So now we have just the list of points. So now we'll loop over these points. We'll loop over the next points. x1, x1, x2, y2. I'm not even saying it right, but you know what I mean. So now we have these, and now we just need to get the area of them. So we can just do area equals x1, what is it, x2 minus x1. What am I doing? This is dx. Okay. And then we need dy is y2 minus y1. And then we can do something like if, well, we can treat them as negative numbers and we can just make them positive at the end. We can absolute value them later. Well, let's just do it now. Dx equals dx, and then chop off any hyphen at the beginning that may or may not be there. It's a little bash trick. We're going to treat it like a string. And then how do you get the area of something? It's just width times height, right? So x times y. So, yeah. So, okay. So we'll do this. Max equals 0. If area is greater than max, then max equals $area, and answer equals oh, we don't need to keep track of which one did it. We just need to keep track of the area of the largest one. Okay, so the max is just the answer. Then we can just echo max. There we go. So if we run this, this should just work. Cat example input, pipe it into part 1. The answer over here is 50. So what do we get? We get 0. So that's not right. If area is greater than max, then max equals area. So clearly our area is never that. So let's go ahead and bash minus x this. Nice job, Bob. So we're getting 0 across the board. So something's not right here. Well, it'd help if I use the right variable name here, right? $36. I don't think that's right. It's supposed to be 40. I feel like I'm doing something very simply wrong here. Let me think. I guess technically we could literally just do this. Like let's not be clever about this. Let's just check every single one, including using yourself as one. Okay, because it should be a very small area if you just use yourself. X2 minus x1, y2 minus y1, make them positive. Dx times dy is the area. If the area is greater than the max, then we set the max to that. And then at the bottom, we echo the max. So that should be fine. Why are we not getting the right answer? Oh, I should get 50, not 36. All right, so how are they getting 50? One way to do this is 2, 5, 11, 1. Okay, so let's do this. X1, Y1. X2, Y2 equals area. Okay, so now there should be one here that's 50. So in this one it says 2, 5, and 11, 1. So 2, 5, and 11, 1. We're getting 36 here. So it is the biggest one. We are just miscalculating it. We could be off by 1. That could be like some sort of thing. And when I say off by 1, I mean just like, oh, we are. That's actually what's happening here. We're literally off by 1. Because if we're at spot 7 and we're at spot 5, that's actually covering 3, not 2. So we just need a +1 to both of these things here. There we go. Now we get 50. Okay, cool. So let's go ahead and comment this out. Let's cat the real input, pipe it into part 1, and we get, well, we'll see if this runs in any sort of meaningful time. I shouldn't have taken out that optimization. Okay, here we go. We get this big number. Let's go ahead and pop this into our thing and see. Go over here. And that's the right answer. You're 1 gold star closer. Hey, look at that. Part 1 done. Yo, what's up, gamer? Just letting you know your head start is over. I am jumping on to part 2.
Yeah, well, I mean, we're fucked.
I love when part 2 is like that. Oh, man, I'm excited. Oh, my God. Do you want me to read it while I'm on stream with you, or do you need this precious time to...
Sure.
Okay, I don't know if you want to crush me or if it's really that bad. Oh, thank you for the congrats, people. All right, let's see.
I have not started. I don't have remotely an approach yet.
Part 2, the elves just remembered they can only switch out the tiles that are red or green. So your rectangle can only include red or green tiles. In your list, every red tile is connected to the red tile before and after it by a straight line of green tiles. The list wraps, so the first red tile is also connected to the last red tile. Tiles that are adjacent in your list will always be on either the same row or the same column. Using the same example as before, the tiles marked X would be green. Okay, awesome. In addition, all the tiles inside the loop, red and green tiles are also green. So in this example, these are the green tiles. Okay, the remaining tiles are never red nor green. The rectangle you choose still must have red tiles in opposite corners, but any other tiles it includes must now be red or green. This significantly limits your options. For example, you can make a rectangle out of these, Oh boy. Oh God. Okay.
Yeah.
Oh, I'm gonna have to sit here and just think about this. Oh, this sucks. Nice job, Eric.
Yeah.
What a part two.
I vaguely remember doing a problem that has a similar solution, and it took me some time. Maybe
Oh
I can
man.
find the video. Maybe I can learn from myself.
I don't think that's cheating. I think that's fine. All right,
I
I'm
don't
gonna
know if I made a
mute.
video for that day though.
I'm gonna mute and I'm gonna lock in.
All right, good luck.
Yeah, you too. All right, she's muted, guys. Okay, hear me out. Eric says, I'm going to have to sit here and just think about this. Yep, that's right. I haven't covered. Yeah, dude, seriously. Like, yeah, like this. Nice job. This is a great part too. Here's the thing. I'm just going to go ahead and say this. I realize my puzzle is 98,000 by 98,000. It's not really feasible. But like, dude, hear me out, okay? This is one of those things where I actually just want to print it out. Like, I want to actually just put this in MS Paint. Like, I want to go through and plot this on a 98,000 pixel by 98,000 pixel image and use the paint tool to just fill it all in. And then I have like my new object and I can just start like searching. Like, I honestly, there's a part of me that thinks that if I visually do this and not code do it, I could get the answer faster. Now I know we're doing it in Bash, but like, you know what I mean? Like, while looking at this puzzle, it's like, oh, this is one of those puzzles. Like, I love these puzzles. One of those puzzles that makes so much sense visually. So yeah. As an enjoyer of visualizing problems, that is a great idea. Yes, exactly. This is one of those problems I think like visualizing it makes just more sense to attack this. Let me go ahead and reread this and really grok what's happening here because, oh boy. Okay. Every red tile is connected to the red tile before, and it's a straight line. So that means that the input you gave us will always have, let me show what I'm saying here. This makes sense, and you say this in the directions, which is nice. I didn't know this in part 1, but you can see that we have a 1 here, so now we have a 1 down here. We have an 11 here, they share the 11. They share the 7, they share the 9, they share the 5, they share the 2, they share the 3. I didn't see that pattern before, but it makes sense that we're drawing lines around the whole thing. Technically speaking, there's no reason why they couldn't share an X twice in a row, and you just draw a line, and then you draw a line again. Like, I could see something like that. They might even go backwards. I don't fully know, but I see what's happening there. So we go over here and we have this beautiful picture of New York. As you can see right here, we got Western New York and we got, you know, New York City down here. Long Island, he didn't draw it. But so that's what we got going on here.
My own code from 2023
Yeah.
has not helped.
Okay.
I am starting to realize why people criticize me when I write code that's a little bit silly looking to read. This, all it says, the ending of this file is, okay, we take the input, we pipe it into fix the elves mistake, then we pipe it into color corners, then we pipe it into modify lengths, then we pipe it into weird algorithm, we pipe it into paste and add it all up.
You pipe it into weird algorithm. Yo, incredible.
Yeah, so weird algorithm is the one I'm not so sure what's going on.
What was that other one you had from a couple days ago? Find 97 or something I think you had.
Oh yeah, it does say find 97.
Incredible. Incredible. Well done.
Yesterday I did have a variable named cigarettes.
It's amazing. All right, I believe we got this.
What the fuck is weird algorithm?
Good luck. This is on you to figure out.
So I actually do remember it. I found it
Okay.
on some like random programming forum.
Oh my god.
So I'm never gonna find that again.
You gotta comment things.
Oh,
You gotta comment.
it's over.
All right.
Bash has failed.
No, we got this. I'm gonna crush you on
Alright.
part 2. Actually, I don't even know how to do this yet, but I'm gonna crush you. I've decided that. All right. Good luck, gamer.
Look,
All right, we got this. We got this. Lock in, guys. Okay, so red and green. The reds are given to us. The greens are created by drawing straight lines between them and then filling in the inside of it. Here we go. The remaining tiles are never red nor green. The rectangle you choose still must have red tiles in opposite corners, but any other tiles it includes must now be red or green. Okay. Yeah, so we can only, well, okay, here's an interesting thing. Wait, this isn't okay. Hold on. I'm gonna say this and I'm gonna regret it. This doesn't seem that hard. I'm gonna regret that. We can only make the same rectangles. There's just less rectangles that we could possibly make. We can, like, we've already made all of the rectangles in my first thing and it ran pretty fast. We just need to pare that list down. Okay. So we just need to make sure that when we make a rectangle, that every single thing inside it is red or green. Okay, I instantly see why this is going to take, why that, okay, I see the problem. There's a name for this problem. You deal with it in video game thing. I'm just going to talk out loud. I'm not going to make much sense here. Video games, when you create a complex collision, you can start with like a really basic collision, and then you can get to like smaller and smaller as you need more complex shapes. But like if you have a big wide area, like I think Minecraft does this with chunks. If you have like all air to the ceiling, it like can optimize that because it knows it's all air. I'm describing a compression algorithm basically, like when you, but like a lossless one. So when we get closer, we can actually start doing this. So we need like some sort of like, I'm going to throw out words that are wrong, bloom filters type of thing to be able to definitively say like, yes, there are definitely red and green in here, or there might not be green and stuff in here. Again, I'm throwing things out in the wind here. We're in the brainstorming session of figuring out how to do this. Yo, Sticky Rice, thank you for the Prime subscription. Yo, appreciate it, man. This is the first day of the year where I'm totally unsure how to tackle this. That's kind of how I'm feeling. Like I have a solution in mind, but it's slow. It is very, very slow. So like, here's what I'm picturing in my head. I'm picturing an algorithm where I give it 2 corners that I make a rectangle out of, and then I need an algorithm that says, is there red and green between those 2 corners? And then I need like some sort of tree structure that at the top has really big ideas of where red and green are. And then as it gets down into the tree, it gets more complex, smaller things where it knows where the big ones are and the big ones aren't and stuff. So like, let me describe what I'm saying. I know what I'm describing. I'm describing Minecraft. I'm describing chunking. That's not what I want. Let me use the example over here. And let's just start making an example. Imagine if we cut this into quadrants, right? So we have like, you know, the right hand top, the left. Let's just divide it in half. Let's divide it in half. So we have the bottom half and the top half. I want to be able to say like, hey, let's check if this rectangle has red and green in it, and it exists in both the red half or the top half and the bottom half. We need to check both of those, but we need to get smaller and smaller. So like, I'd be able to ask like, hey, does the bottom half have any red and greens? And it would say, oh yeah, there's 8 red and greens. It's like, oh, damn, okay. Does the bottom half left side have any red and greens? No, it doesn't. Oh, okay, cool. I don't need to check that. I've already invalidated it. So that's what I'm picturing. I'm creating this basically from principles. I'm using like Minecraft chunk algorithm. Like I wish I was a better computer scientist and can give you the real name for this, but that's what I'm picturing. Now, how do we do this is the question, because we need a really optimal way, because basically we're going to end up checking every single, here's what I picture in my head. We're going to end up checking every single pixel of a rectangle to verify that it's valid, but we need to come up with fast ways of invalidating it. I need to be able to create a rectangle and almost immediately be like, nope, that is invalid. So let's start storing our information in a grid. So we can't get away from this. We're going to start storing our information in a grid. Let's not edit part 1, part 2. Okay. And then vim part 2, and let's go ahead and create a grid for this. Declare -a map equals this, and then we're going to say map key equals the pound sign. That's what we're gonna do. That's what we're gonna do here. So I think we're onto something. And then I'll have to just grab this logic again, but that's fine. I have it in part 1, safe there. So now we have the map. We store the map there. I'm going to go ahead and lift a function from a previous day. Bad Cop and I discussed this. We don't consider it cheating because I have a print grid function. I don't feel like rewriting from scratch because, as you can see, I've written it a bunch of times. Day 07 part 2. And we're going to put it into day 09 part 2. There we go. So let's go ahead, take this, copy this over here, and now we have a nice little print grid function. And we even do some nice coloring, so let's go ahead and keep that going, because if we want to color it, we can actually make it red, which is nice. So if this character's that, it's red, and if it's an X, then we will make it green, and if it's not anything, then we will just print it as is. It'll just kind of fall through. So we've created a map, we've got that, let's go ahead and print grid. So if we run, what is it? Where am I? Okay. Cat example, pipe into part 2. That looks horrendous. I know what's happening. A couple things are happening. We don't have a character in there, so we need to do that colon equal a space. So we need to just default it to be a space if it's not set. And then also I print a pipe character here. That is not what we want. We want the pound sign here and the X sign there. There we go. Okay, well, that's cute. We're almost there. Make it a dot. That's what I wanted. I defaulted an empty space to an empty space. Hey, that's cute. That looks really good. Now we need to draw lines between all of them. So now we need to, here we go. Read the entire map. Draw lines, green squares, between points. So we need to read this in the exact same order we got the input from. So I'm going to go ahead and just steal the input. So what I mean by that is we can just say map file -t input, and now we have an array of all the lines of input. So we can do this. Instead of reading from standard in, we can just loop over it. We're getting really gross here. I don't like this solution, but here's what we're gonna do. Okay, here's what we're gonna do. We're going to say input equals read in from dev standard in. We're going to read the entire file into a string. And then we're going to put that string here, because then we can duplicate this logic again. Cleaner ways to do this, but here we are. So now that we're reading it again in the order we got it, we can draw a straight line between the two. So the way we do that is we can say previous x equals x, previous y equals y, if dash n previous x, then we have the one before it and the one that we're currently on. So that's what we want here. So now we have our x and our previous x. So let's go ahead and say cur x and cur y. So we have our current x, our current y, our previous x, and our previous y. That's great. Okay, so now we have that. We can say something like echo comparing prev x, prev y to cur x, cur y. Let's go ahead and run this. Okay, cool. So now we have to not compare them, we have to draw lines. So draw line from prev x, prev y to cur x, cur y. So that's what we have to do. And then we have to make a function that does that. So let's go ahead and make our draw line function. I need like something that can, I need like a helper to do what I'm doing right here, because I'm just a lot of boilerplate code. Okay, there we go. So now we just put it in a function. We didn't change anything, so we should just get that. Awesome. So now we need to actually use the right variable name here. That's awesome. Now that we have that, I'm going to change this to bash -u, which will blow up if I use an undefined variable. because I apparently don't know how to program. So it wants this to be defined. There we go. So, okay. So now we need to draw a line between the two. So we need to figure out what direction we're going to draw a line. What that means is either the y's are going to be the same or the x's are going to be the same, and we're going to move left or we're going to move right. So we have to figure out which way we're drawing. So if prev x equals cur x, then moving side to side, else moving up and down. I'm going to be crazy logical here. We're going to say prev y equals cur y, then moving up and down, else echo uh-oh, and exit 1. That's what we're going to do here, because now we at least know what's going on. I have no clue how can draw lines plotted coordinates. Oh, we're going to have some fun. We're going to figure that out together. Don't you worry. And I'm going to be duplicating a lot of code to accomplish that. So buckle up. So if we're moving side to side, we don't technically need to know if we're going left or right. We just know that we're going side to side. So we're going to be modifying the x here. So let's go ahead and write this out. For x equals prev x plus 1. We don't want to override a red square ever. X is less than, not less than equal, less than cur x, x plus plus. That could be dangerous because we're going to be moving left to right. So we have to figure out what direction to go. So basically we need, we just need to find the max, the min. Is that what we need? We could just do the max, the min, or we could also figure out direction. Also, this should be down here. Moving side to side. Yeah, let's do this. This is gross. Min x equals prev x greater than cur x. If that's true, the minimum is the cur x. No, if the prev x is less than the cur x, then we want the prev x. Otherwise, we want the cur x. Okay. Now we just have to do this a bunch of times. Max y. Okay, min x is this. Max x would be if the prev x is greater than the current x, then we want the prev x. If the prev y is less than the cur y, then we want the prev y. Otherwise, we want the cur y. And if the prev y is greater than the current y, then we want the prev y. Yeah, this seems right. This seems right. So now we have a max and a min, which is nice because what we can do here, if they're the same x, then we know we need to loop the y direction. So for y equals min y plus 1, y less than max x, not less than equal, less than y plus plus, do, done. And then the same thing goes down here, but instead of, we just use x and we use min x plus 1, and then x is less than max x, so that should be max y. As you can see, there's a lot of room for bugs here, so that's fun. Cool, so now we have that. So this is how we're going to handle for moving side to side. Oh, I just had these comments wrong. If the x's are the same, we're not moving side to side, we're moving up and down. If the y's are the same, we're not moving up and down, we're moving side to side. Okay, so now we need to do this, and now we know y equals, it doesn't matter which y, they're the same. So y equals cur y because they are the same, and x equals cur x. So we'll do local x and y. Okay, so now in order to do this, we need to check if the character is a dot, then we change it. I think we could be cavalier about this. I think we're safe. But let's say if the character that is at map Y, let's go ahead and make a key. The key is X comma Y. If the character that is at map key is equal to a dot, then map key will now be equal to an X. And this is a green tile. We'll do the exact same logic in here. And I think that's it. I think that's it. Now this doesn't fill in the squares. This doesn't do anything. How is that unbound? We have map. I'm just not going to trust bash minus u. Hold on. Let's print grid again here. Well, Dave, Bad Cop is completely derailed, trying to convince chat she's a fishing villager from Minecraft, so you might have a small lead. Oh, a small lead? Isn't a lead what the Minecraft wandering trader drops, I think you're talking about? I don't know. I got some Minecraft knowledge. No, that's awesome. Oh, man, dude. The fishing villager. Those guys are funny. What do the fishermen get you at the end when you, like, fully max out their trades? I don't remember if they were good or not. The farmers give you the golden carrots. Those are awesome. You're talking about barrels and going, Oh, good. So she's completely derailed. That's incredible. I'm happy to hear that. We apparently have code that doesn't work. So that is pretty cool. Oh, we're checking to see if it's a dot. It's not equal to a dot, guys. I'm stupid. It's equal to nothing. So let's just do this. We could use a dash Z instead. Hey, look at that. The one thing we didn't do is we didn't wrap it. So we can do that. We can wrap it around the Christmas tree. We can wrap it. It is pretty. I really like the way that looks. That's really cute. I do like the red and green. Oh, dude, Eric's derailing me now to balance things out. Dude, I think you're right, man. I think you're right. So we just need to do the wrap. I'm trying to think of clever ways we could do the wrap. We have the whole input here. I think the easiest way to do the wrap is to just, hear me out, ready? Because we have the input still, we can just read it one more time. We have it in a giant string. IFS equals comma, read dash R, cur X, cur Y. Previous will be the final thing because it's still set from the last time. We're going to read it in again, and then we're just going to call one more draw line because we have those same variables set. I think that's all we need. Wrap the puzzle. There we go. Now, I haven't done any okay, perfect. That works. I haven't done any validations of the puzzles. So what that means is I haven't checked to make sure we're not like overwriting anything, but I don't think we're going to. Eric's pretty good about not giving puzzles that break. Also, he specifically says in the page, it says something that they're going to follow each other. That's why the same X's are the same Y. So it did match that. We never got the uh-oh problem. So this looks beautiful. This looks great. We are on to something here. We need to, we need to fill this thing in. This is so easy for me to do as a human. Like, this is so stupidly easy. But how do you do this as a computer? I can think of some cheater ways. If it's against the edge of the map, then you go to the opposite end of it and you're definitely inside it. But you need to figure out, like, let's imagine this like a computer. If I'm here at this X, how do I know to go up or down? How do I know which one's inside and which one's outside? Because what I could do, ooh, okay. Oh no, this is easy. Sorry, it's not easy. I gotta stop saying that. Start at the edge of the map. Start at the edge of the map and draw a ray in. So start at the top or start at the left-hand side and draw a, so let's imagine we start at the top, draw a ray all the way down until we hit one thing. The next side of that is inside the thing. So we can get a coordinate that is inside the thing. We can do it like that. Oh my God. Okay, hear me out. This sucks. Hear me out. This sucks. Hear me out. Let's do left to right because it's easy. Start from the left. And we're in no fill mode. It's going to be, we're going to toggle, we have a flag if we should fill or not. Start from the left, go to the right. Once we encounter nothing, we don't fill anything. But once we're going this way, We hit a pound sign, so we are in fill mode now, right? We are in fill mode. So, no, I don't think this works. Hold on. There's got to be some algorithm I'm just missing here. Because if we're in fill mode, then we should start filling stuff. Now we don't have to fill anything here because all this stuff is fill. Once we go here, we're not. We hit this, we're in fill mode, so we start filling. We go here, we're in fill mode, so we start filling. We go here, we're in fill mode. Actually, this might work. Okay, let me... Now that we're here, let's fill the inside of the map. Here's what we're gonna do. Guys, I don't know. For y equals 0, y less than height, y plus plus. Do. For x equals 0, x less than width, x plus plus. Do. Done. Done. When we get to a new column, we start fill mode as a 0. And we're going to toggle it. But we reset it to be a 0 here. So then we are drawing a ray all the way to the left, and we're going to see what happens. The character at that spot is key is x comma y. The character at that spot is map key. Okay. If c equals... We can't keep turning it on and off. We'll have to keep track of a couple variables. If c equals a pound sign or c equals an x, then we have to think about this because we can't just keep toggling it because, okay, imagine this scenario here. If we're here and we hit this pound sign, we turn on fill mode. We don't turn off fill mode. We don't change fill mode until we encounter... Oh no, how do we... Oh, dude, okay, I haven't thought this through. Because I could say, let's go here, and then when we encounter a space, we're still in fill mode, so we're still filling stuff. But how do we know we haven't left the puzzle? Like, imagine there wasn't a space here. Imagine it was just scrunched together, and it was just a line. How would we know we're out of the puzzle? This is where I'm saying the human touch, man. Imagine if I just looked at the big puzzle, hit the stupid paintbrush, the fill bucket algorithm, and just hit it. Like, I don't... Okay, technically speaking, I don't... Yeah, I agree. I actually agree with Brett Twitch. This is a very nice problem. I really, really like this. Like, this is awesome. I could just generate the puzzle and then just fill it with a paintbrush tool. And that's totally valid. I know that's totally valid. But I'm like, okay, well, that puzzle's way... Oh, right, it's like 90,000 width and 90,000 height, isn't it? All right, well... Let's do that without printing the grid. And let's just make sure we can actually get to something, right? Let's just make sure we can actually, like, if we give it the real input, that it can actually... Okay, it can finish in a good time. That's what I wanted to make sure it could do. So now, we'll have to come up with a way to visualize the grid for the real input. We have a syntax error because we don't do anything. How do we figure out that we are inside the puzzle? And that we haven't left it? Because we could just be going, like, you could have lines just snake up and down, and you don't really know when you're in and out. Okay, when I draw a line... I could keep track of all the lines. Oh, yeah. Wait a minute. Hold on. I could keep track of all the lines and all the corners. I have all these things. Oh, I'm just reinventing the same algorithm. Hold on. Because I want to know if I cross a line barrier. Like, if I'm going perpendicular to a line, I don't care. But if I'm crossing a line barrier, that is absolutely when I care. Okay, hear me out. Ready? We implement the paint fill algorithm. We implement paint fill, you know, a nice little depth first search or breadth first search of pixels. And we try to paint fill from a random pixel, and we see if we hit the wall, the edge of the map. If we hit the edge of the map, then our paint fill failed. Can you... Okay, here's another question. Don't answer this. This is a rhetorical. I'm thinking out loud. Is it possible to get a landlocked pixel? So I'm imagining an algorithm like this. I pick a pixel at random, or, you know, iterate through them, whatever. Can I get to the edge of the map? Because I feel like with a pathfinding algorithm, I can check if I'm able to get to the edge of the map. If I'm able to get to the edge of the map, then I know that I'm not inside the thing. But I could imagine you could make a line in such a way that landlocks a pixel and makes it stuck, where it wouldn't get filled. Hopefully that makes sense. I could contrive a scenario where that exists. I should probably check that to make sure that actually is real. But actually, let's do that. Why was it hanging down there? What was it doing? Oh, was it just running? I don't know what it was doing. Maybe it wasn't. I don't know. Whatever. Let's ignore that. It's Christmas Minesweeper. Yeah, exactly. Let's make simple input dot text. Okay. So here's what we're going to do. We're going to say 4, 7 to 7, 7 to 5 to 8, 7. Now we're going to say 8, 2 to 4, 2, and we're just going to see what that looks like. Okay, we've made a nice little square. I don't think we can landlock because of the wrapping. No, I think we can. A 4x5 square. Listen. Yeah, I didn't think about that. Oh, good thing I put my uh-oh in there. I'm awesome. We went to 4, 2. So we're back at 4, 7. So we want to go down to 4, 10. Yeah. Unless I'm drawing it wrong. But I'm like totally imagining like a scenario like this. I made a P. That's pretty cute. Are you planning to solve this by drawing the whole grid? I'm not going to be hand drawing anything that's 90,000 by 90,000, but I do plan on coming up with some sort of algorithm that can do that for me. Now, how that actually works in practice, I have no idea. The colors are really nice. What I need to do, because I'm contriving these scenarios, but I don't even know if my algorithm's like perfect. Because now we go down to 4, 10. What if we went to 8, 10? Okay, then we have an error. I think we're okay. I literally think we can go to... It's 90,000 by 90,000. We can't do this in any sort of reasonable amount of time. I was like, we could just go to every single pixel and try to figure out if we can start filling from there. Although then we start negating, then we have less and less pixels to fill. It's literally Minesweeper. It's the Minesweeper algorithm. Like, what do we do? Let me think about how to do this. trying to think of when fill mode turns on and when fill mode turns off. We might, if I store the lines with their direction, like this is a left-right line, then I know that if I cross it on an up-down boundary, I've crossed the line. And if I cross it from left-right, I have to go this entire distance before it's considered crossed. Yeah, so basically, like I would make a bullet tracker where it's like not in square, not in square, in line. Now I am suddenly in a line that starts here, and when I get out of here, then I'm not being in a line. So I'm like developing a state machine that knows when it's inside a line and when it's not inside a line. And when I go through a line, whether it's a line of one thing or it's a line of multiple things, that I need to change my fill mode from on to off. I need to toggle my fill mode, starting it with off. I think I need to do that. How would I know when I'm in a line? I need to have every single line's starting position and end position and the direction. So I need to store an array of lines in both directions. Okay, this sucks, but just I'm going to go with this idea for now, and we're gonna see if I can get anything meaningful out of this. Horiz lines? No. I'm stupid. Horizontal lines, I'll forget that I did that. We're going to have an associative array of horizontal lines and an associative array of vertical lines. And every time we draw a line, we are going to keep them. So when we're drawing a line here, we are going to say vertical lines, because we're moving up and down. The key here will be the starting position of the line. Dude, this sucks. Hold on. I really need a good data structure for this. Let me study this image a little bit more again. Yeah, I basically need to, given any point on the map, I need to be able to say, am I inside a line? Where does the line start and end? And if I hit this, then I'm actually inside two lines. Then I know I'm at a corner. Yeah, the real input is brutal. The real input is 90,000 by 90,000. So it's a big set of input. And I can't really store. Oh man. I really need a good data structure for this new ugly sweater merch. Yeah, I could see something like that. Oh man. Chris in the YouTube chat, no suggestions, please. You didn't technically give me a hint or give anything away. I just want to say no suggestions, no backseat gaming, please. I'm gonna figure this all on my own. I gotta beat Bad Cop by my own merits. But I appreciate you jumping the stream. Don't get me wrong, I'm not upset or anything. Just letting you know, no spoilers or suggestions, please. Unless it's like something obvious, like if the suggestion's like, yo, code better, like, dude, based. I understand. Might have to go downstairs and grab like a root beer or something. Maybe that'll make me code better. Yeah, I need an algorithm that, given a X and a Y, can tell me if I'm in a line quickly. I'm sorry, I'm not a programmer. I thought I had a good idea. Dude, you're fine. You're fine. Don't be upset. It's totally okay. No apologies needed. I'm just letting you know. I'm using your comment as an excuse to remind my chat, hey, no spoilers, please. I appreciate it. But no, dude, yeah, you're totally welcome here. I love it. And if you want to like problem solve along with me, I'm cool with that. I don't want to risk any spoilers. So sometimes when people say something and I don't know if it is one or not, I err on the side of just being conservative and being like, hey, please no spoilers. That's what's going on there. So you're good. You're good. I might have to play some piano. Let me do a little piano break real quick. I could make, here's what we could do. I could make an indexed array of every single line that we have drawn. So there will be a unique number for each line. Each line will have a number. This will be line 1, this will be line 2, this will be line 3, yada, yada, yada. And then I could make an associative array of every single one of these. And when they point to a line, we will actually put the line numbers in it that they intersect with. Okay? So now when you have coordinates, I can look up to see if you're in a line. And if you're in a line, I know information about that line. Let's try that. Let me put these variables at top. Okay. So then when we draw a line, we will store it. What will we store exactly? I have no idea. We'll store something that says the line. We'll just put as much metadata in here as we can think of. So this is a up-down line that goes from previous X, previous Y to current X, current Y. I don't know if we'll need all this metadata. We're over storing everything we could possibly need. And this is a left-right line that goes from these two. So now, every single one that we draw there, we can store in a different map, line map. So for every single one that we encounter here, we will add it to the line map. So we need the index of this line. Line number equals the length of lines. This will be the index. So now we can say lines at line number equal this, and we will know that this equals the line number. This is garbage code, man. This is garbage code. But we're on to something. We also need to store the min y, comma, the x doesn't change, and the min y, we need to plus equal that with a space around it, and then we also need to store the max y. This is so garbage, dude, but we're gonna see if this does what I want. I'm going to be printing out a lot of variables at the end of this. I realize how confusing this is. Min x, max x. Okay. So now that we have that, let's go ahead and pull in our var dump. So let's see. Yo, what up? Equal slash, how you doing? So now we have line map and lines. So let's var dump line map and var dump lines. Here's what I think we can do here. Yo, what up? I'm doing well. I'm doing pretty good. Cannot assign list to array member. Okay. That makes sense. Yeah, I can't use this list notation because I'm directly assigning it to the index that we've created. Okay. Do I have an exit in my code somewhere? I do. Okay. That code didn't work. Okay. Here is what we have. There's a lot going on here. So we have this, and then we have the line map. So every single one of these coordinates has a line. Some of the coordinates have 2 lines that go through them. That's because they are a corner. If they have 2 lines, they're a corner. Think of this like an array. And if they have 1, then this is just a line that goes through it. And when you want to look up information about that line, you use that index. So like number 6 here, you would go to this array down here, grab 6, and we can find out that's an LNR line that starts at 2.3 and goes to 7.3. Hey, that's pretty cool. That is pretty cool. That's pretty awesome. Okay, so let's start doing some work. Because now I think with that information, we can do what I was talking about. We can go from left to right, and we can start doing something. So, yo, what's up, Seekne? How you doing, man? Thank you for the Prime sub, dude. I appreciate that. That's awesome. How nicely indexed. Thank you. When you have Bash, you have to learn how to do things, because I don't have 2-dimensional arrays here, so I have to get gnarly with it. Looks fun. I'm stuck on day 5, part 2 somewhere. I calculate the answer wrong. Dude, I have been there. I have absolutely been there. Yeah, if you try doing a bash, you go insane. Bro, I feel that. I think I'm onto something. I think I have a solution I can work through. Yo, good luck, Dark Space. Yo, appreciate it. I think I have a solution I can work with. However, I need to get a drink. So I'll be right back. I'm going to go grab a drink. I'll be right back. 1 minute, going down to the fridge. I'm back. Got a nice 0 sugar mug root beer. Chair stream. Dude, I love my chair live reaction stream. Oh, the Cardboard Dave. Oh my god. Cardboard Dave is going to be replaced with a Christmas tree sometime this week. So, yeah. Of course, a Unix admin has a root beer access. Root beer. Yeah, that's right. That's right. Yo, we got the root beer stream. I'm a mug man. All right, let's do this. Let's crush Bad Cop. So here's what we're going to do. We're going to draw arrays from left to right. And mods, please ban Dave Eddy. Wait, no, don't make me say that. Why would you do that? Let's see. We're going to draw arrays from left to right. And we're going to see once we're in a line, then we're going to start getting some information about the line that we're in. What information that is, I don't know yet. But we're going to start getting some information. So for y equals 0, y less than height, y plus plus, do. For x equals 0, x less than width, I already had this code, why did I get rid of it? Plus plus do, done, done. Okay, okay. The stream wouldn't be as interesting if you used a programming language, the full standard library, etc. to do these right. I agree. When I get really struck, like it hasn't happened this year, but last year doing this, when I got really stuck, I'm talking 5 hours in, I would switch to Rust, solve the problem because I had it in my head, but I couldn't make Bash do it. And then I would go and retrofit it, backport it, go from Rust to Bash. So yeah, sometimes I do that when it's really bad. Yo, congrats on finishing part 2. That's awesome. Now let me finish part 2. We need to grab the character that's at the map of $key. We need to set $key equals to X, comma, Y. So now that we have the character that is there, if the character is no, we don't even need that. We don't even need that. Yeah. Rust confuses me. Dude, I love Rust. Rust is where I go, like, if I need to bang something out really quickly. I love it. Oh my god, I'm not worried about likes on the stream. You guys don't have to worry about liking the stream. If you're watching on Twitch, go ahead and follow me if you want. If you're watching on YouTube, you can like the stream. That'd be awesome. Go ahead and hit the subscribe button. Go ahead and hit that subscribe button. How about for enunciating? Let me do this. Okay, here we go. I'm gonna lock in here. So now we're gonna check. We have the line map. So if we don't even need that C thing, but there. Lines equal line map of key. If dash Z line, then we haven't hit a line. Now let's do if dash N line. Then we'll go ahead and we'll read the lines out of it. Because there could be multiple lines. If we're at a corner, we're going to have 2 lines intersecting there. Echo hit lines at key. Let's do that for now. And let's see what we get, because we're drawing rays from left to right, if I'm doing it right. Okay, there's a lot of stuff going on here. So let's get rid of these var dumps, and let's only do the first row. We shouldn't get anything here. Yeah, we shouldn't hit a single line on that one. The line we hit should be on the next one. Now, why we have a whole set of blank lines at the top? I must be off by one thing, but that's where we are. Oh, because Eric's puzzle does not start at 0. Okay. I assume. I don't know. Whatever. It doesn't even matter at this point. Let's, if y equal 2 and exit. That's what we'll do. Okay. We hit 2 lines at 7, 1. So this is 7, 1. We hit this. Then we hit 1 line, 1 line, 1 line, and then we hit 2 lines. And then we hit 1 line, 1 line. Okay. We're off to a really, really good start. Like a really good start. This is great. So we'll do this. We'll say fill mode equals 0. We always start at 1. We're always 0. We're always starting at 0. Okay. Here we go. Fill mode is 0. And then we get if there's a line there. If dash Z line, there's no line there. And fill mode equal 1. Then map at key equals X. Hey, we're starting to do something. Now we don't have all the logic there yet. Elif dash Z line and fill mode equal 0. Then don't do anything. I'm being very, very verbose. We're being very, very verbose here. Starting to do something is the first step of doing something. Yes, exactly. This, I hope, okay, I'm not actually joking when I says, I hope I can impart this lesson onto anyone watching me right now. I don't think I'm like the best programmer or anything, but what I think I excel at is being able to break things into smaller steps and not giving up. Like, you know, when it's like the tortoise and the hare and everything, like tortoise all day, baby. Discipline. Just keep going, make one step, put one foot in front of the other, and eventually you will get there. Like, I hope I can impart that on here. That's what I love about these puzzles. Like, you do them and eventually they're done. Like, it's awesome. It's awesome. Yeah. Okay. It's like an old Reddit post you did. Eric, what are you doing? Are you trying to distract me from working? You're really on bad cop side, just aren't you? That's what's going on here. How much she paying you? Is it good money? I'll pay more. Do I need to donate? AOC plus plus plus? Oh god, Eric, this is a long post. I will keep it up. I will read it later, but I can already see at the top of this, I would recommend the ability to break problems into smaller problems 8 years ago. Yes, yes, yes. There are no such thing as complex problems. Well, there are such things as complex problems, but they're meta. Complex problems are created by a series of smaller problems. If you can break them into simple problems, it's like 5 times 2 times 3. You can't do that. You have to do 5 times 2 and then times 3, or 5 times 3 and then times 2 is commutative. The point is you can't do complex operations. You have to do simple operations multiple times. Cool. Awesome. Let's see. You do it and eventually it's done. Yes, exactly. Exactly. Complex problem is a problem made of similar problems. That's what complex means. Yes, yes. An apartment complex is a building made up of smaller apartments. I remember I said that to my, oh my God, I said that to my ex-girlfriend when we were in college. We said something. She was like, yeah, something about the forest through the trees. And I was like, you can't see the colleges through the university, or you can't see the university through the colleges. Like some stupid thing like that. Okay. I love you guys in the chat, but I got to lock in here. We got to actually just focus. So here we go. If there's no line and we're in fill mode, then we set it to an X. If there's no line that we've encountered and we're not in fill mode, we do nothing. We just continue on to the next one and we check it. If there is a line there, we need to see what lines there are. So now we're just going to write case statements over all these. So we're either going to be in a 1 or 2 lines situation because we're either at a corner or we're not in a corner. So if it's at 1, then not a corner. And if it's at 2, then is a corner. So if it's a corner, we have to get the line out that we care about. And if it's anything else, then it's an uh-oh. Okay. Let me go ahead and just run this. Okay, I just want to make sure we did not get an uh-oh, because that means that we're doing something right here. Yo, what's up, NMBB? How you doing? Okay, cool. So we hit a corner first. If it's not, okay, let's just think through this. If we have not hit a corner, what do we need to do? We have hit a wall. We are going left to right, so we need to figure out what kind of wall it is to care about. Technically speaking, we can't hit a left to right wall on the X's. We have to hit a corner or we have to hit an up and down wall. So let's go ahead. If it's not a corner, then we'll get the line out of it, which will be the lines at spot 0. And then we can assert that, let's read dash R direction X1, Y1, X2, Y2 out of that line. And then we can assert that direction equal, if it's a line and we're going from left to right, it has to be up, down, echo. Well, let's just do, let's make a function called uh-oh because of how many times I write this, okay? This will solve this problem. Why didn't I do this from the beginning? Why? How is it taking me this long to figure it out? There we go. We have an uh-oh function. So, this is fun. Let's go ahead and just run this and make sure it works. We have hit an uh-oh. That is not good. We hit 1 at 8, 1. So this is 8, 1 here, I believe. Oh, no. We need it to be... Oh, no, we can hit a left-right because... No, I'm wrong. Okay. Nope. I liked my idea, but not the right idea. If it's a corner, get the line we care about, which will be the left, right one. So we have to figure out which line is the left, right one. So we'll do this. If direction equal up, down, then we'll do it again, but we'll read from line 2. And then we'll assert that the direction equal left, right, because that's what we're getting out of it. We don't know the order, but we're going to get that out of it. Okay. All right. Okay. Good. We did not hit any sort of assertion failures. Let me go ahead and just comment this line out. We're going to process the entire file. We have not hit any assertion failures. Hey, that's awesome. Okay, I hate how indented this is, but, you know, whatever. Okay. If it's not a corner, we have this. If it's a corner, then we get the direction we care about, which is the LR one. So if we have hit a corner, we now have the LR line, and we know it's the beginning. So we need to figure out how far it's going to go. Calculate how long it is. Okay. So if we have this, then we can figure out how... We can just figure out where the next one is. Oh my god. Okay. I got this. So we have the x2. We need the longer of the two. We need the max of the two. So max equals x2 greater than x1, x2, x1. I don't remember if it was sorted or not. So now we have the max x, and we just need to jump to that location and toggle fill mode. So fill mode, it's a 0 or 1. So fill mode XOR with 1. So we're toggling it on or off. I think this is right. I might be a little bit wrong here, but we're working on it. And we have the max X. We can just jump to the max X. So we have X up here. We can just say X equals max X. That's it. So we can skip the entire line effectively if we hit a corner. That's beautiful. That's beautiful. Okay. And if we hit a single line, we need to check what it is. If direction equal LR, then it's the same thing we've already done here. If we've hit the LR thing, let me see. If we've hit the LR thing, then we just need to do the exact same thing we've done here. We already have this logic. We can't do this. This can never happen. We actually can't get this. This situation can't happen. Uh-oh. So if we're down here, then we know the direction is an up-down. We just need to skip past it. We just need to toggle fill mode. That's all we need to do. I think we have it. Okay, well, the fact that it keeps hitting it is not good. So we have some sort of infinite loop. It's probably because I'm modifying X while I'm inside the loop, but we can figure that out. Hit 2 at 7, 1. Hit 2 at 7, 1. Okay, yeah. So what do? We get the max X, and then we try to jump there. Oh. Hold on. No, that's right. Jumping X from X to max X is what we're doing. Jumping X from 7 to 1. Okay, so we're just going right back to the beginning here. That is not good. Put some debugging in here. Okay, well, none of those variables are set. What do we even put in this stupid thing? Prev X, Prev Y, cur X, cur Y. Is that right? Yeah, wait, what am I doing wrong here? Yo, what's up, Seeknate? Yeah, dude. Thank you for jumping in. I appreciate it. Have a good night. This is reading from line 1, this is reading from line 2. This should work. Let's go ahead and bash minus X this. We're very close. It's just getting 0 out of that. Oh, wait, I'm reading out of the wrong thing, aren't I? No, we're not. We're not. Here, you know what? We got a corner here. Let's go ahead and var dump lines, and let's exit 1. There we go. Let's go ahead and get rid of this bash minus X. What do we have here? Okay, we encounter this, which has line 0 and 7 in it. That's all well and good. Yes, that's just not right. It's because I'm reading out of the wrong data. I have to actually get the line. I have to get the line that's at, this is the index of the line. Yeah, where do I start? I make a variable called line. I'm overriding a variable. That's what I'm doing wrong here. Lines hit. Curse you, Bash, for not having nested data structures. Hey, okay. I mean, we hit an uh-oh, that's not great. But something's going on here. Hit 2, okay. Seven, 1, and 11, 10. Yeah, we got the left, right 1 from that. And the direction. The direction equals LR. Oh yeah, no. This is right. Just that's needs to be negated. Let me just toss a print grid at the bottom of this. Yeah, we do. We do have the file. This looks pretty good. We do have the file system. That was you are right there. This looks pretty good. I think we got it. I think we absolutely have it. Oh my god. Okay. 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 Now we have it. We have it. We have it. So, okay, oh wow. Okay. Heck yeah. I'm going to go grab some stuff from part 1 where we did this little check at the bottom. This is where we went through and we calculated every possible thing we could check. We need to do this exact same thing. We had an array called points. Do we set points anywhere? We do. Okay, so we have an array called points. We go through all of them. We don't have any sort of whatever. We go through all the points here. There's no optimizations. And then we check the area if the area is greater than the max. That's great, but we need to check check if this rectangle is valid. Okay. Is valid x1, x2. Nope. Gotta be consistent. x1, y1, x2, y2. Otherwise, continue. That's what we have to do. So now we need an isValid function. Okay. We have draw line. Do we have any other functions? No, we just have that. Okay, now we just need an isValid function and we're good. Okay. 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 Now we are ready to make an isValid function, and we have to check if these points are valid. So for x equals 0, local x, y. For x equals... We need to do the same thing here. Let's just steal this. We're just going to steal exactly from the draw line. It's just going to work this way. Because we already have this here. Okay. Okay. Sorry I'm not keeping up with chat. I'm kind of locked in here, but I do like this comment. There's only several people on this platform that have his attention to detail. I hope you're talking about me. That's a very nice compliment. I appreciate it. Sorry I'm not giving you guys my full attention right now. I am trying to race this creator up here. And I'm going to win because I'm crushing it right now. X equals previous x, x, nope. Min x, x less than max x, less than equal. It can be in that square. X plus plus. Do. Y, y, y. Max y, y. Okay. Done. Done. All right. Now we have to get the character for that. No, we have to get the key. Key equals x comma y, and then we have to check if dash n the map at the key, meaning it's set, then it's valid. If it's not set, it is invalid. So if dash z, then return 1. It is a failure. Otherwise, if we've checked every single square and there's something set there for every single square, we return 0. I think that's right. Let's go ahead and run that on the example. We get 24 here. If we go over to this, the largest rectangle you can make in the example using only red and green tiles has an area of 24. Okay. I don't know how long it's going to take. Well, it's going to take less. It's going to take less. Oh, yes. This is going to take less then. Input.text. Cat it. We can't print the grid. We cannot print the grid. I would love to, but it's going to just be too slow. Yo, I am locked in. Appreciate it. All right, I don't have any debug output for this. I wish I did. But it didn't take that long if I remember from part 1. We could put debug logging here. I will give it a minute to run, assuming it's going to finish in some good time. But if it's not, then I will, yeah. Oh, man. hope I'm not stuck somewhere. Yeah, I'll give it some time. I'll give it some time. Yeah. Let me cruise on my phone real quick. Ooh, new YouTube upload. Let's go. Oh, this was uploaded yesterday. What a lie. This is going to take a little bit long. Let's... Because I have to do more checks now. We can optimize this. J, we can do I is less than points minus 1. And we can do J equals I plus 1. So that we do get an optimization here. And then we can say echo checking let's do this. Echo checking I out of points. There we go. Is there any way to get a thread dump of a bash process to kind of see the progress? It would depend on the operating system. I mean, we definitely could do something like that. Not probably easily on my Mac. What is happening here? What's the part that's taking a long time? Where are we echoing? We might not even be down there, now that I'm thinking about it. So we have all the lines drawn. Okay. Okay. Filling it now. Echo filling Y out of height. Okay. This I have a hunch that the filling is going to take a while. So that was my hunch. Yeah, so this was my hunch. And I don't know a way to optimize this faster. If we were in a different language, this would be so stupidly fast. So stupidly fast. But this is not going to run in any sort of meaningful time. So we have to make the fill algorithm faster. Which makes sense. This is definitely like not the fastest algorithm that's ever existed. 30 hours, nice. Yeah, so this isn't great. We definitely need to start optimizing this a little bit. To think about how to do that. Yes, we are. We're not allocating the full grid. We're just keeping an associative array where the key is the parts that are set. Oh yeah, so as we start filling it, we are going to start... Yeah, you're right. Hold on, you're right. As we start filling it, we're going to start keeping track of this stuff. Yeah, okay. Yeah, this is a problem. Now that we're filling that array with stuff, the associative... Like, now that we're going through the fill algorithm, this isn't great. So we need a more optimized way of storing what we have filled. Okay. Also, the example output fails now. Why am I getting 15 when the answer was 24? Are we just getting the wrong answer now? What did I change that would have made it fail? What did I do here? Let me make sure all my variables are local. That's the first thing you got to check when you get into this situation. Okay, well, at some point I broke this script. And I don't really know how I broke it. Let me think. What did I do to break this? Did I do something wrong here? I did not. Okay. I want to watch this VOD back later and figure out what I changed to just suddenly break it. I'm not getting the right answer now. Because that looks right to me. Oh wait, I've seen this problem before. It's no. So it's just it's considering the one that gives me 24 to be invalid. None of these are giving me 24. We're getting 15. Getting nothing here. Oh, because I'm calculating it down here. Okay. Let's just do this. I just need better output real quick. Okay, yeah, we're getting 24 down there. They're just not considering it valid then. So why? What did I do? What did I change? Did I not update the map somewhere? What am I doing? Not valid because key. Let's see. One way is between 9,5 and 2,3. I'm reading the page. 9,5 and 2,3 should give me an area of a lot larger than 6. Yeah, how am I getting 6 from this? Nine comma 5 and 2,3. 6 and 1 Should be, that's not 1, that's wrong. Nine comma 5 and 2 comma 3. Yeah, that should be 8 things times 3 possibilities. Should be 24. I can do the math right here. We're getting a dx of 6 here. That's not right. And a dx of 1 here. Neither of those are right. What is happening here? x1, y1, x2, y2. Is it because of the +1? Do I need to do this? I do. Okay. Yeah, I need to do absolute value before I do the +1. Cool. Not exactly a thread dump, but Eric wrote a pretty neat tool to see what the shell pipelines are doing. That's interesting. I'm going to pop that open too. That's very interesting. Because I have a long form video planned where I actually I use dtrace on a Lumos to show what every single part of the pipeline's doing, and I plan on writing a small bash style shell parser, so it won't be super featureful, but like you could run ls pipe this pipe that, and it'll actually show you all 3 running. Like, so I plan on visualizing it. So if that's something here, oh my god, that could be fun to show off. Progress of reads or throughout pipes. Oh cool, throughputs of pipes. That's cool. Similar like a PV command, I think, does that, pipe viewer. It's called pipe viewer, and it can actually like modify things, which is wild to me. I'm not a hater, it's just interesting. Sort of like PV, yeah. Okay, cool. So here's my issue. Now that we have this information and we have the working algorithm again, we're not going to be able to run it this way because I'm using the fill operation to turn on every single bit. That's not gonna work. That is not gonna work. We need to store an optimized version of the part that we've turned on. I've mentioned this before. I mean, that's what we have to do. We have to be able to say, we have to quickly be able to throw out invalid rectangles. That's what I'm trying to say. We have to very quickly be able to throw out invalid rectangles and then take the time to check the ones that could potentially be valid. I'm thinking like Bloom filter type of thing here, but I don't know what this data structure actually, I don't know how to do this, because when it comes to making these fills, if we think about how we're filling the puzzle, the way I'm filling it, it's not optimal. We could fill it differently. We could fill it by drawing the biggest rectangle inside our area first, and then looking for overlaps between the rectangles. So that might be the way to do it. Let me think. We take whatever weird shape we get. I'll show you. We have this. This is made up of 3 rectangles. We have this rectangle at the bottom, 3 by 2. We have this rectangle up here.
Progress report. What was going on?
Progress report. I came up with a solution that would work if I had unlimited RAM. So what I'm doing is not working. Yeah, so like, I mean, I could write out to the file system. I don't know how big this file is going to get. I think someone calculated in my chat it might take 30 hours to run. So
30 hours might be faster than it takes me to finish my code, you know?
Dude, this puzzle's hurting me.
I did make a cool little guy that can print out the grid, so that's...
Ooh, fun.
Got that. It's not going to be useful because obviously if I run that on the input, my computer's going to die.
Yeah, I don't know about yours. Mine's 90,000 by 90,000.
Yeah, it's pretty big.
Yeah. I have some ideas. I don't know how to implement them, so that's kind of where I am right now.
Yeah, same.
It's like I have a solution that will work if I have infinite time. So now I'm just going through the standard process. Now I'm like, okay, how do I optimize this? How do I do this faster? Use a different language.
I don't know if a different language is. Well, I think you could churn through it with a different language. Like,
I know I'm with you on this one. I actually think this solution takes a little bit too much RAM. I actually don't think. I think if I used Rust or something, I would actually just max out my system faster than Bash would.
yeah.
Yeah. So I don't know. I got some ideas. I can keep working on it, but like yeah, I'm not stuck, but this one is really difficult.
Yeah. Not too many people have finished. I was looking at the leaderboard.
Oh,
maybe
interesting.
now they have.
I didn't think about doing that.
Three people have got it so far, but also Eric says that he figured it out. So.
What, Eric? Oh my God! I didn't know
he was bragging that he did it like weeks ago.
What?
And I'm like,
okay, well that seems unfair. I didn't realize he was cheating. Okay, this changes everything. On my private leaderboard, no one has gotten this puzzle.
Nice.
Yeah.
Right,
oh no, that's not
first.
true. That's not true.
Oh.
Someone named Ben got this puzzle. It looks like they don't have a ton of points, so I didn't see him right there. I should have sorted better. One person has gotten this one.
Let's go, Ben.
Eric says he solved the puzzle. Yeah, see, Eric, get out of this chat. I didn't realize you were cheating. Oh, another person in my chat, Dragon Wizard, said I solved it in Python, which is cheating. That is cheating, so you're right. Yeah. So yeah, I don't know. I still got some juice left in me. I think I can come up with some. I should be able to come up with something.
Why
tonight,
do we
I
not
think.
have like better geometry handling things in the core utils? Like, what's up with that?
Oh my God, I
They
know.
don't have, like,
we should be able to pass
polygon
vec2s to each other.
Who's working on this?
Eric said, "Don't make me add myself to the top of your leaderboard." That'd be kind of funny. I'd respect that move.
Does Eric have all the stars? I feel like they can't be legit.
Yeah, I don't
Those
trust
are definitely
it.
spawned in.
Exactly. Insert into stars. Yeah, come on.
/give command.
That's so funny. Oh, Eric says he has all the stars and a time machine. I've built a couple time machines with these puzzles.
Yeah, that's true. I'm still going to. What I was saying earlier about like, oh, I was hoping today would be a quick one so that I could get dinner. I think at some point I'm gonna have to take a break to get food because I did not eat before the stream.
Gotcha. Well, I mean, it's already 2 a.m. here, so I might only stream for a little bit left. Yeah, exactly. But we'll see. I'm hoping I can come up with something clever.
Have you tried weird algorithm?
No, that's the thing. I tried to pipe it to weird algorithm. It said something like command not found. So
yeah, you gotta install it.
Yeah, command not found. Bash. I don't know what that means.
Bad cop utils.
All right, BC utils install.
No, BC is a different program. That's the basic calculator.
That's the arbitrary precision calculator. Dude, someone in YouTube chat just said, "Eric, what's the answer?" Okay, that's like the best message I think I've gotten all night. Yo, Eric, 14. What's the answer? Like,
yeah, can you look up just... I don't want to know, like, the approach that's the answer. Can you tell me, like, what number I should put in the box?
Yep.
If you could just type that in the chat, I'll copy-paste it. We'll be all good. -1. Now, it could be. Is that what I'm supposed to say if there's no valid rectangles found? If my input just doesn't contain any red tiles? That would actually be crazy. I know you can't do it because it wouldn't work for a lot of reasons, but imagine if one of the days the input was just like a blank file. Imagine how confused everyone would be.
God, it's fun. Just the days where the input is like a 2-line file. I'm like, oh, we're screwed.
Yeah. Oh, we're doing math today.
Basically, yeah. Okay, I just had an epiphany. I have an idea. All right, I'm muting. I'm locking in.
Oh, he's
Yeah, that's what I'm doing. All right, I have muted myself. I had an idea. Okay, so here we go. All the encode ones are? Yeah, I could see that. Hint, there's something about the shape that you can use. Listen, I said no hints. No hints. No hints at all. I do not want hints. I say no spoilers, and both titles do not give me hints. I also don't plan on using that hint, but no hints. No hints. Do not give any hints. Even if you're like, that's not much of a hint, doesn't matter. No hints. No hints at all. Remove your message. Yep, so no hints, please. Not mad at you. You're fine. You can hang out in the chat. I'm not upset or anything. Just no hints, please. I have an idea, though. So my idea is we're doing... I already have an optimal way of getting this information, which is I have the array of all possible lines, and then we use that array to fill the puzzle, right? So we fill the puzzle, which explodes. Think of it this way. I don't know if it's going to make sense to anyone. We have an array of lines. We have an SVG file. I then go through my algorithm of filling the puzzle or rasterizing it. So now we have a ton of memory being used by this stupid thing. And then I go back and check that raster data for pixels in a certain spot. That can be cleaned up. Instead of rasterizing it, meaning filling up the array of all the filled in things, what I have to do is I have to keep my SVG of lines, and then I need to check, oh, if this rectangle is valid in this square, I need to check how many lines I need to draw from this rectangle. I need to check all the lines above it, to the right, to the left, and below it, and all the lines that are within it. So I think we can do this. I think we can do this. Yeah. Solution uses bash. Okay, that's a hint I'll allow. So here's what I'm thinking. I don't know if that makes sense. We have to not rasterize it, for lack of a better term. So our filling the puzzle thing, we don't want any of this. There's got to be a better way to do this. I'm going to take this whole filling the puzzle thing, and we're going to just bring it down to the bottom of the file, and we're going to put a exit 0 down there. So that's what we're doing. Now we've looped over all the points, and we're checking to see if the points are valid. So these are the 2 points we're checking, and we just need to call is valid on them. Once we get here, we just need to check if they're valid. So we just need our is valid function. And we have the draw line. We do. We still call draw line. So now we just need is valid. In order to check if something's valid, we can't use the map anymore. We're not filling the map. We are just going to check every single line in there. That doesn't seem right. Let's check for any... to figure out how to do this. Okay, so we have this, and we know it's unfilled right now, but we know where all the lines are, what their direction is, where they start, and where they end. So we know a lot of good information here. So if we were going to draw a rectangle like in here, let's just imagine we check every single point. We don't have to do this, but if we grab a point from that rectangle, we can go up until we hit a line, we can go down until we hit a line, we can go left until we hit a line, we can go right until we hit a line. So we can start coming up with ways of invalidating them. If we're in a rectangle and we're inside a line, that spot is valid. If that pixel is not inside a line, we draw a line up. Oh my god, oh my god. For every pixel in a rectangle we're trying to draw, it's, again, not the fastest thing in the world. For every single pixel in a rectangle we're trying to draw, we draw a line straight to a wall. All 4 cardinal directions. We need a better algorithm for this, but it's fine. If we hit a wall, we increment a counter until we run off the map. If the counter is odd, then we are okay. If the counter is even, then we are invalid. It's not the most efficient thing, but I think this will work. So we check this, we check this, we're checking all these points. We have a new rectangle to check, x1, y1, x2, y2. Okay. So this checks every single pixel. Perfect. So now we check every single pixel. We have to get the lines out of it. Holy crap, he's a genius. I'm not. This could be totally wrong. This doesn't mean that I have it right. Let's make a new function. Is pixel valid? And then you cache it! Dude, and then you... No, you don't cache it. Stop it. No, because if you cache it, we're going to run out of memory again. Okay, maybe don't cache it. Why did I just... See? I'm not that... See? I'm still stupid. Okay. We will call is... we call is valid. Is pixel valid or return 1. Is the pixel of X and Y valid? And then we check every single pixel of this. So okay. There's so many loops that I'm creating here. This can't be more efficient. This just can't be more efficient. I don't think we have to check every pixel. I think we have to check every corner. Yeah. Either way, let's just do this. Let's just do this and see if we can get this to work. We can optimize this too. For new x equals x, x less than width, new x less than width, new x plus plus. We're gonna go to the right. Okay. If we pass through a line, then the line is crossed. Okay. If you pass through a line, then the number of lines is crossed. And then we get to the bottom. If lines crossed is modulo divided by 2 equals 0. If we crossed an even number of lines or we didn't cross a line, then we are invalid. We failed. Okay. Get ready for something gross, guys. Now let's go to the left. Okay. Now let's go to the right. Nope. Let's go up. Yo, thank you, NMBB. Have a good night. Appreciate you stopping by. And now let's go down. Now, there's so much optimization that can be done here. I don't know if this algorithm is going to work, but there's so much optimization that can be done here. So we're still in a good place. Okay, so the answer is 0. So that's not right. It's not considering any of these to be valid. So let's do this. After the first one, we'll just stop and we'll investigate what's going on here. We call is valid on it. Is valid checks every single pixel. If any of those fail, then we instantly return the pixel check. And the pixel check does this. All right. Invalid, right. Oh, you know what? Okay, so every single one was invalid, right? Well, that's not true. We don't know that. Invalid down, invalid down, invalid down, invalid left. We literally walk in every single direction. I mean, it's gonna be slow. Oh yeah, this isn't right. It's the same problem as last time. We have to jump up if it's a, we have, we have to do this logic. It's so much code. I have to shrink this. It's going to be right. Like, this is going to work, but it's a lot of code. I need to optimize this. Is pixel valid? Travel and direction. Let's just make a count lines in direction. We need to make this smaller. That's where we're starting. Okay. The bash course will be coming up sometime this month. I don't have a firm date on that yet. It'll be out before New Year's. That's as firm as an answer as I can give. It'll definitely be out in 2025. So soon. We got to figure this out. Count lines and direction. We have an X, Y, and then we need to know the direction that we're going in, which determines something. Okay, I have an idea. We're going to write this out and then we're going to optimize it later. While true, we got to figure out the direction the user wants to go in. So we need to take that. It's $3, and that will determine what we do to I and what we modify. So case direction in L. If we're moving to the left, then we do X minus minus. Okay. If we're moving to the right, then we do X plus plus. If we're moving up, then we do Y minus minus. And if we're moving down, then we do Y plus plus. And then we don't need to do anything with that. And then we just need to check. while we just need an inbounds check. So we'll just put it here. If x is less than 0, or x is greater than equal to width, or y is less than 0, or y is greater than equal height, then we break out phi and we'll return 0. So yeah. Did you say mic doesn't work? Can you not hear me? I think my mic is working. All right. Let's see. Okay. And then we just simply return lines crossed modular 2. Oh, that's true. If you're new to my stream, you might think it's Bad Cop stream. I never even thought about that. Okay. So now we have a pixel, we have a direction. Let's go ahead and just check it. We get the key, we get the lines there. If there's a line there, nope, we need to do more. If there's a line, we gotta do this. Good thing I've written this code already. Oh boy. This code is unruly. So this is how many lines we have hit at this thing. So we're either at a corner or we're at a line. If there are lines here. If -c line, then we don't do anything. We need all this crap to run. Ugh, I hate writing code like this, but we're so deep into it. We're nesting. If the line is set, then we'll check how many lines are hit. We hit this many lines with the key. If we're not at a corner, then we extract out the line that we care about. We get the direction. It can be either direction. I didn't even think about that. We're close. We're close. Depends which direction we're going. We can't override direction. If there's a line there, then we have to check if it's a corner, if it's not a corner. If it's not a corner, we have to see what direction it's going in. If it's doesn't actually matter. We just need to get the max. Because we know what direction we're going in. Yeah, that's all we need to do is we just need to get the max. So like case, let's get this. Let's get the max. And we need the minimum Y because we're actually going down or up. Oh God, we need everything. We need everything. Okay. We have the min, we have the max, we have the max, we have the min. Okay. Okay. Yo, thanks for stopping by, dude. I appreciate it. It's all good. We'll get this done. We'll get this done. It's happening. It's happening. So now we need to case over our direction. Am I just modifying it down here? Oh my God, am I stupid? Okay. So now we have the min, the max, the min, and the max. Now we can case over our direction. If we're going to the left, then we want to update our x to be the min x of that because we're going to the left. We're just going to skip over this whole line. We don't need to check it because it's always going to be valid if we're in a line. If we're going to the right, then we want the max of that. If we're going up, then we want the minimum y. And if we're going down, we want the y to be the max y. And then, of course, we'll put our uh-oh case here. So this is how we skip over these lines. It will always be valid. So, yeah. The ternary operator is only valid in that math context, like you note. Now we need to get the line we actually care about. So, if the direction that we managed to get is up, down, and our direction is equal to I can't figure this one out. Let me think. There's only one line we're going to care about. If we're moving up and down, we only care about the lines that are up and down. It'll have a higher max. Yeah, if we're moving up and down, then we want the direction to be either up or direction to be equal to down. If the line that we're looking at is for up and down, but we are moving left or right, then we need to reread it. That's what I'm saying here. think we're good here. Okay. And then once we do that, we've successfully skipped over a line. So if dash n is a line, then lines crossed plus plus, because we jump over them. Okay. Now we need to check count lines in direction. No. We need is valid in direction. Okay. Okay. Now we can do is valid in direction x, y, l. Otherwise we return 1. I think this works. Okay. Where's our syntax error? 93. I didn't close a parenthesis. Okay. This indentation is making it hard to read. Okay. So we found 0. That's not right, obviously, but it went pretty fast. We were able to very quickly get 0. So that's pretty fun. Let's just check 1. Okay. Okay, now we have is valid. Okay. Okay. Checking if 7 comma blank is valid. So I must have put some bad debugging here. I wrote prex. Checking if 71111, checking if 71 pixel is valid, checking if 71 left is valid. So that one failed right away. That should be in there. Crossed 0 lines. So 7-1 is here to 11-1 is here. That did cross a line. It crossed itself. I think I'm missing like a +1 somewhere. Yeah, because if it exists solely on a line, I mean, I don't mind calling those invalid, to be honest. 'Cause they're never really going to win. It's not right, but... Okay, so now we're going to look for 9, 5 and 2, 3. Here we go. This is the one that's the biggest, or this is one of the ones the biggest. This crossed 0 lines. Okay, so that is not right. She has functions named Wahoo Yeehaw Enterprise Func. Yeah, see, you got to be careful with that because it becomes really hard to debug those. I mean, I have indents in my log, so you know, I'm on my own thing. Okay, so when you go to the left, it just crosses 0 lines. So that's not right that happens. Okay. Yeah, like these are pretty big ones. If it crosses 0 lines... Oh wait, if it's on a line... It always has to be on a line when it starts, right? Okay. I can't tell if I'm in an infinite loop or not. Make a grid debug only, not for prod. Incredible. Okay, we are in an infinite loop. Okay. We're in an infinite loop. It's like going back up. To move to the left, we go minus minus. To go to the right, we go plus plus. To go up, we go minus minus. And to go this, we go that. Okay, that makes sense. If we're going down, we set it to the max Y that we found, the biggest Y. And we also plus plus it. We need a lot of debugging here. Setting Y from 1 to 1. Okay. Setting Y from 2 to 0. What direction are we moving in? James, I have no idea what you're talking about in the YouTube chat. If it's anything to give me solutions or hints, please don't say that, but I actually have no idea what you're saying. Okay. Checking down is valid. We start at 7-1. We hit a corner at 7-1. Setting Y from 1 to 1. Now we're at 7-2. We're at 7-2, and we set Y from 2 to 0. And if we're going down, we should never do that. That means we're going backwards. Setting Y from 2 to 0. Y is max Y. If we're going up, down, if the corner we've read line is up, down, and we're going left or right, then we need to reread it. We care about line blank to blank. So that's what's going on here. So we somehow got down here without having any sort of valid thing that we've read. So that's not right. Debug line equals 7. Yeah, we need to do this. This was never working. That was never working. Okay. Again, I don't even know if this algorithm is correct. I think it is. So according to this, none of these are valid. Let's come up with the simplest example that should be able to produce a valid rectangle. So, checking if 4,7 to 8,7 is valid. So this is not valid in the up direction. Should be, but it says it's not valid in the up direction. We cross two lines. It's considering crossing itself. Yeah, dude, Eric, I feel that I probably gotta jump off soon too. Appreciate the luck. We'll see if I can get it tonight. I'll probably do like another 20 minutes and we'll see if I can get it. But yeah, I mean, I knew I'd hit a puzzle eventually that would cause me to go into the next day. So here we are. I'm not even upset. That's how it happens. I see what's happening now. I'm crossing over a line. I'm crossing over my line. That's part of the puzzle. I probably shouldn't care about if I do that. Or I guess I'm always... It's always going to cross over one or two. Okay, so we got 30 on the simple input. That should be 50. That should not be 50. It should be 24. 50 was part 1, right? Yeah, 50 was part 1. So we're getting a part 1 answer. So we're doing pretty all right here. What's happening here? Where's my example? There we go. Yeah, so we're getting 50. It's not right. So we're calling too many things valid that are just not valid. Let me think. 50 is here. Let me check the inside. I don't know what you guys in YouTube chat are talking about. I appreciate you telling me to take breaks and sleep on it. I'm not going to do that. I'm locked in and this is getting done tonight. I appreciate you worrying about my well-being, but we're getting this done tonight. We're going to do the inside here. $21. Not quite, but it's something. So the one that should be right here is 9, 5 to 2 to 3. There we go. All right, so this one should be valid. It's valid in the L direction. It's valid in the R direction. It's valid in the down direction. It's valid in the up direction, right? Not valid. Because it crossed 2 lines to get there. So 9 to 5 to 2 to 3. We should be checking these pixels. I see how you cross 2 lines. You got here and you got there, but they're the same line. It's okay. We should have jumped you up there. Shouldn't have happened. My algorithm is wrong, but we're really close. I'm going to look specifically for that case when we're checking here. Checking 7, 4, going up. 7, 4 going up is invalid. 0, 1, 2, 3, 4, 5, 6, 7. This is invalid going up because it crossed 2 lines. So that is wrong. Oh wait, did I say 7, 1?
What's up?
Yo, did you get it?
No.
Oh.
Here's some stuff. I'm drawing.
Oh my god, that's awesome. No, I'm chasing down what I think might be a bug, but if I fix this, I don't think I still have it either. So.
Yeah, I think mine's gonna be kind of slow.
You think so?
I think it's like n cubed territory, which is like 100 million.
Oh my god. Okay, that's not good. I don't know. Mine seems solid, but it doesn't work. So there's that problem.
What n is it? Would you like food for thought? No.
Wait, what?
No, not really. Someone in chat asked if I want food for thought.
Gotcha. Yeah, no, some people try to give me hints. I'm like, even the hints at this point, I'm so locked in, like, it doesn't even matter.
Yeah. Yeah, I'm doing what I think I'm doing. It's just.
Yep.
Will it be fast?
Yep. Can I
make
actually?
it faster?
Can we actually get it to work? I don't even know. I have no idea how fast or slow this is gonna be when it's all said and done. To be honest.
I'm looking at your code. Oh,
yeah. Good luck.
LRDU as well. I have that in there.
Do you really?
Yeah. Yeah.
Oh my
You
god,
gotta
that's
figure
funny.
out- Ooh, lines crossed. What the fuck is that?
Oh, you're cheating by looking at me.
No, mine's different. I don't do that. Oh, that's interesting though.
Yeah.
Yeah, I'm not doing that.
Oh god. I mean, I'm afraid to ask you what you're doing because I don't want to get ideas, but now I'm kind of curious because I'm so like set in what I'm doing here.
Um,
Thank you, Narf.
I mean, I think the picture is pretty self-explanatory.
You know, I don't even have your stream pulled up, so give me a
Yeah,
second.
I think it explains itself really.
I'm afraid to see what picture is about to come up here. Let me share this. Yeah.
I think that pretty much tells you what's going on here.
JSPaint.app. Let's go.
Yeah,
Oh
we're doing
my
some football
god.
plays.
This is so
The
funny.
quarterback can only go, the blue quarterback can only has one direction. You can only go infield. The
Okay.
red quarterbacks, they can go all over the place. They're
Oh, I see.
hacking.
I get it.
Go
Okay.
this way.
No, Bob Bad Cop still did not get it. So we are both chasing down two completely different solutions. You're
They're
making
actually
football
different kinds
plays.
of quarterbacks, yeah.
Oh my god. This is so funny.
But I made my look at this, let's do a little exit. One of these. I see. I mean, I made it draw the football play. So,
Yeah. Yeah.
So that's a good start.
Oh my god.
We got Wahoo, Enterprise Funk, make it graded, debug only, not for prod.
Eric was saying that these were the name of your functions. I thought half of them were
so
lies.
Wahoo's self-explanatory, but what you really want to do is pipe in a little yeehaw in there, and that's gonna flip it around.
Yep.
And then yeah. I wonder what happens if you do two yeehaws. Oh, you're back to normal. Yeehaw is sort of
Two yeehaw.
Boolean operation.
Oh my god, this is a cluster fun. This is incredible. So do you feel like this is gonna happen, or are you gonna call it quits and go get dinner?
I think I'm gonna have to. I'm probably gonna call it at midnight and then come back.
Okay. I think I might do like another 15 minutes and see what I can get done.
Because I got to the hard part where I started copy pasting code from part 1, and I'm like, oh,
Yep.
I'm on 150 lines and this doesn't do anything yet.
Oh no. That's not good.
It's gonna be good once it starts going.
How fun.
Your solution has more promise than bad cops. I'm closing this stream. You're gonna be impressed when mine runs in less than 12 hours and it gives me an answer. So
Bro, I'm gonna be afraid when that happens.
let's go.
Incredible. All right, I'm gonna go lock in. I'm gonna lock in for the next 15 minutes, and I think I'll call it.
All right, I'll raid you, and then you can.
Heck yeah! If I'm still on, I'll raid you, of course. I think I'm close, but I keep saying that, so I might not be.
Narf, are you gonna be impressed if I get an answer with this solution? Because it's gonna work. You're just. Took me 110 minutes to figure it out in C#. Like, it took 110 minutes to run? No, right? Okay, I'm gonna get food. Bye.
All right, see ya. All right. We're gonna get this. We are gonna get this. Oh my god, thank you, Bad Cop, for the raid with 56 viewers. Wow, can you believe Bad Cop just averages double my view count? It makes perfect sense. I think she's a way better streamer than I am. But yo, I appreciate it. Welcome everyone over here. Sorry, things are way different than what goes on at Bad Cop stream, so we're gonna try and get this to work, but there are no promises. I can kind of see what's going wrong here, but yeah, this is gonna be fun. I think we're caring about the wrong thing. Okay, so when we get to the line, we care about 7, 3 to 7, 1. Yeah, we're jumping over 2 lines, so we don't want to do that. If we're going up and down, which we are, then we care about we're good. We're doing something a little bit wrong here, but if the line that we're looking at is going up and down, but we are moving left or we're moving right, then we need to read it again. But if we're going up and down, which we are in that case, we should care about that. So what's happening here? Checking 7, 4 is valid. Okay. 7 over 4 down is valid. And we're checking it in the up direction. So then we go up to 7, 3, which means we cross through a line. There is a line there, and it is a corner, and we care about the X and whatever line. I see what's happening, but we're already on a line, so we shouldn't have to care about it. Yeah. So we're moving up and down. We should be grabbing the up and down one, right? Yeah, this seems right. We're caring about the wrong line here. Yeah, we're at a crossroads and we grab the wrong line. That's what's happening. Then we reread it. Well, it'd be helpful. Hear me out. It'd be helpful if we read x1, y1, and x2, y2. It'd be helpful if we read the right variables there. Hear me out. It'd be helpful if we didn't have mistakes in our spelling. It wouldn't be helpful because we still get the wrong answer, but at least we're on to something. Okay, crossing line at 7, 3. It's a corner. We care about 2, 3 to 7, 3. That is not true. We do not care about that line. We care about the other line. Yep, so we're doing something wrong. Oh. or dir equals left, right, and direction equal up, or direction equal down. Oh my God, that's the answer. That is the right answer for the example. This is going to be flooding us with information here. There's no way this works. Oh, we can't print the grid. Gotta remember this. Can't print grid. We will not process if we try to print it. We're gonna see if this works. We might be onto something here. I don't think 0 is the right answer. Gonna be honest. I don't think print grid debug only, not for production. Okay. So I'm happy that Bad Cop felt the same way about printing the grid. It makes perfect sense. But I do not think 0 is the answer. So that's not great. Oh, probably because we're looking just for this one right here. So we have this little thing here. Let's cat the example and pipe it into part 2. This is gonna generate. Okay, it still works. Cat the real input and pipe it into part 2. I forgot I had an exit early in there. Huh. That might not be good. Let's go ahead and get rid of some of these echoes. What do you say? Okay, what we need is better debug output. We need something like this. Checking I/that. Okay. Okay. So that's 0 out of 496. I think it has to loop through 496 here. And then it goes back up to 1. I still don't think this is going to be that fast. Let's go ahead and get some more output in there. Yeah, I don't think this is going to work because we have 2 nested loops here. The 496 should be how many pound signs or, hash marks or corners appear in my real input. Yeah, I don't think this is going to finish in any sort of timely manner. Now, the nice thing we could do here let's start optimizing our code. So let's start optimizing our code here. Here's what we can do. I have some things ready to optimize. Didn't I put comments like optimize this? I thought I did. We check every pixel. But we don't need to do that. We only need to check the corners plus 1. So here's what we can do. If we need the delta, max x minus min x is less than 3. I'm trying to come up with exit earlies. Like, we only care about squares that are of radius 3. This might fail, but I think this is right. Now that we have this, we can just check the actual corners. So we can do is pixel valid of min x plus 1 max, or sorry, min y plus 1. Or return 1. I think we can do this. Hi, Dave. Greetings from Poland. Yo, what up? Welcome. Welcome. Fast fail like a boss. Exactly. Exactly. That's the goal here. I want to fast fail as fast as we possibly can. So we want the min x plus 1, the min y plus 1, the min x plus 1, and the max y minus 1, the max x minus 1, the max x minus 1, and the min y plus 1, and the max y minus 1. So I think this will be a lot faster. It's faster, we get the wrong answer. So it's a lot like collision detection. Yeah. Okay. Don't understand why that worked. It's not order of operation things, right? Has to be at least 2. I think that's right. Can we get an idea of how fast the real input works? Faster, but just so incredibly slow. 'Cause, I mean, you have to churn through 90,000 directions, right? Is there any way we can make this faster? Yeah, I just don't know. This is not going to work because I has to count up to 496 and J has to count up to 496 times that. So it's not going to work. Yeah, I might have to call it a night here. I don't think I'll be able to get this. Yeah, so I don't know how we would even approach this. Run in background. This is not going to finish in like an hour. This is going to finish in like multiple hours. I think it'll just take too long. Yeah. So I have to come up with a different solution to determine if the rectangle is valid. Yeah, it's just going to be too slow. I think I've exhausted my ideas for the night. Just like I'm picturing it in my head. I guess we don't have to check every pixel or even a corner. We can just check one, right? No, we do need to check every corner. Okay. Yeah, I don't know, guys. This is gonna be brutal. I don't know any way to make this faster. The parallel, it's just not fast enough. Like, even if we did parallel processing, we would need a lot of processor. I don't love this algorithm. There's got to be a cleaner, faster algorithm for this, I'm thinking. There's got to be a faster way to do this. I keep thinking about, like, there's a name for this algorithm. I can't think of what it is, but like we look at, like, we generate the entire map of all this, and then we create rectangles. So, like, there's 3 rectangles here. There's one rectangle here. There's one rectangle here. There's one rectangle here. And we could just come up with a way, instead of sorting every single pixel, we sort every single rectangle that's there. And then we check for collisions, like a full intersection, basically. So it's like a video game bounding box type of thing, where it gets more precise as you get closer, when the hitbox gets more precise. But when you're just checking, like, hey, is there something on the left side of the screen, that's way faster than, hey, is there something at this specific pixel coordinate? So I'm thinking we want store it somehow. We're gonna, I don't know how exactly. We'll have to divide, store, divide, store, divide, store. Like, it's a tree, basically. I just don't know what that is or how you'd create it. So how you would derive that from, like, first principles. So yeah, I don't know. I think I'm going to call it here. I'm not going to come up with an answer. It's been over 3 hours. I'm tired. It is, I'm not in Bad Cop's time zone, so it's 3 a.m. for me here. So yeah, I think I'm going to call it here. Sorry, Bad Cop, you're not around. I would raid you normally. So if you're watching me now, please go back and watch Bad Cop when she starts streaming again. Yo, appreciate it. Thank you, Amex. That's super nice. Yeah, so well, I'll probably stream this again and we'll try and figure it out. We're gonna come up with a clever answer for this, I think. I'm thinking it's a sampling problem. Like, if I want to test if a rectangle's there, I have to take 4 points from the rectangle. I have to take the 4 corners of the rectangle and then check to see if they're fully within the thing. So, yeah, I don't know. I'm going to call it here. Thank you, everyone, for watching. I appreciate it. If you're watching on Twitch, go ahead and hit that follow button. If you're watching on YouTube, go ahead and hit that subscribe button. Most likely I'll be back tomorrow. If I'm not, it'll be some other time this week. But I'll be here. We will figure this out. I love puzzles like this, dude. I live for this kind of stuff. So I'm having fun. I think this stuff is great. So, yeah, I'm going to call it a night. See everyone. Thank you so much for tuning in.